this is how long it's going to take. Really, for every task, there are three, well, there's a probabilistic distribution of how long it's going to take from a likelihood point of view, right? And so we can talk about the worst case and the best case at kind of the either extreme of that distribution, and then the expected case in the middle. So let's identify what the best case and worst case effort and duration are, capture those. We're going to use the expected case as the published estimate. We're going to try to take steps to prevent the worst case from occurring for each task. We're going to try to take steps to enable the best case to occur for each task. And we're also going to look at the variance between the best case and the worst case estimate, because that will give us a sense of the accuracy of the estimate overall. Excuse me. A combination of those would be called the wideband. Now, this all sounds very theoretical and ritualistic, but I mean, the way that I would approach this typically is just sitting in a room with the test team, having a conversation task by task. How long do we think this is going to take? What's the best case? What's the worst case? What's the expected case? And it's not very ritualized or anything, just a systematic discussion of each task. Where do we feel? Okay, so let's say in our hypothetical case study here, we go through, we estimate effort and duration, find a missing activity, smoke testing, and look at variation, best case and worst case. Go, okay, it could be a 25% swing either way. The best case is 25% less, and worst case is 25% more. Identified the risks and listed them. Those would then get pushed into the test planning process, right? So in the test planning process, we would take steps to deal with the risk. Now notice that here I'm talking about project risks. I'm not talking about quality risks. I'm talking about things that could happen that would affect our ability to carry out the project. Now, notice that at this point, though, the initial list was, the task list was put together by the manager or lead. At this point, the list has been vetted by the entire team, and the effort and durations came from the team. They did not come from the manager. So the level of commitment is going to be higher. Right? I mean, that's just natural. If you tell somebody, I can do that and it'll take me this long, then it's sort of a point of pride, if nothing else, to make it, to get it done in that length of time, right? Okay, so now our estimate looks like this, which is a funny looking thing. It's like everything happens all at once and then we're done in 5 days, right? Or 15 days, or this is the longest one, creating the load capacity, volume, and reliability. This, by the way, I should, in a real estimate, you'd want to break this down finer because it's too long. But, obviously, this is not the way it's going to work out. Because one of the things that we're still missing is dependencies. There's got to be some set of dependencies that exist between the tasks, right? You do this before you can do this, before you can do this. So the project management terminology, we would talk about predecessor and successor tasks. So the predecessor task is the task that has to be done before the successor task can start. Now, it's not always, that's called a finish start dependency. We have to have finished the predecessor before the successor can start, but you can have variations in that, like you can have a finish start where the start can start a day before the finish, where the predecessor is actually finished, so some portion of the work has to be done. So there are a lot of different variations here, but ultimately we're talking about tasks that are somehow linked with some sort of dependent relationship. And in order to determine the dependencies, what we will want to do is start by looking at the tasks that have no predecessors, the ones that we can start immediately upon the approval of the estimate. Imagine that we have all of our tasks in a list or in a stack of note cards, index cards or something like that. We can go through that and take out the index cards that have the tasks that no predecessors. Okay? And you can go through the stack, again, the list of tasks, and say, okay, these tasks depend only on those tasks which had no predecessors. And then go through the list again and say, these tasks depend only on those tasks which depended only on the predecessors. And you can repeat that process iteratively until you've identified all the predecessors for the tasks. And that is literally one way to do it. You put a schedule up on a whiteboard. And when I say schedule here, usually it's just week numbers across the top, and then just stick the index cards or the post-it notes under the week numbers as they go along, and use a marker to indicate the dependencies between them. So at the end of that process, your whiteboard is covered with all these sticky notes that have the task names on them and the pictures of the dependencies with little arrows in between. And that works really well for medium to large projects. So you might need a big wraparound whiteboard for a large project. You can actually visualize the whole thing at once. On a smaller project, you can just do this in Microsoft Project or some similar tool. The reason that you can only really do that right in the project itself is you want to be able to see all of the tasks at once. And so you're really limited to about 30 to 40 tasks on a screen at one time in something like Project. If you're not looking at all the tasks at once, it's difficult to make sure that you're checking all of the dependencies. So having established the dependencies, we can now look at the critical path. And so the critical path is just a fancy way of saying a sequence of tasks where if any task slips, that's going to cause the end date to slip, because that slip is just going to rattle along through those dependencies, and ultimately the last task to finish is dependent all the way along that chain, so it will slide out. Okay? Now you can also have near critical path tasks, which is there's a dependency with a task that's on the critical path. Now currently the way it's scheduled, it's going to be done 3, 4, 5 days before the critical path task starts, so it's not going to have an impact, but it could if it slipped enough. So we want to look at those because that's another source of risk. Anything that could delay a critical path task is a project risk, because that's got potential impact on the end date for the project. You also want to look at phase entry and exit criteria, because these are typically bottleneck points on a project. Now, they're milestones that have to be satisfied before a whole bunch of other tasks can start. So they're typically going to be on the critical path, these entry and exit criteria. So you want to look really carefully at those to see what are the risks associated with not meeting those. Okay? You want to think about how many test passes you need to run through, how many times you need to run through your test set, how many test releases do you expect to get. Hopefully you're not going to assume, oh, I'll just get one build and find all the bugs in it, and then get another build, and then we'll be done. That's usually not the way it works. So we want to think about that. And you also want to think about external dependencies. So any sort of handoff that's coming into your team, test releases, test environments set up, anything like that, that can also be a cause of delay. So we want to understand that. Okay. We also want to assign resources at this point. So resources would include people, test environments, and then the tools and data and test cases and other stuff, testware. Okay. So people, test engineers, test technicians, they could be contractors in some cases or employees. You use outside testing resources, like you might choose to use a outside test lab to do some particular thing, performance testing or what have you. Now, it's important to keep in mind that when you assign someone a lower level of skill to a task, that is going to increase the effort and duration for a task. Now, the reason